Hey guys, so this video is for anyone who might have missed class or wants to go back and review some of the things we talked about. So I'm not going to go into as much detail about what a logarithm is or why we need it and that kind of thing, but I am going to do the example problems so that you get some look at translating logs. So we talk about in class that logarithms are an inverse of the exponential function. So in order for us to solve something like this, 5 to the x power equals 20. In order for us to figure out what x is, we need logarithms. So there's lots of different places where we use them, mostly just for solving exponentials. Mostly there's a necessary undoing, right? Kind of like a square root, but not exactly the same thing, to help us get through and solve some problems. So this is essentially what a logarithm looks like. We have usually the word log, and then we have some small base, which is a subscript, and then we have some number here, which is our argument, and then finally our answer. So a log essentially answers the question of what is the exponent we need. So for example, if I've got log base 5 of 625, and that's how we read it, what this log is going to tell us is how many times would I need to multiply 5 over and over and over again to get 625. Let me move my face here. So the answer to this, if I were to throw this into a calculator or just answer it myself, the answer is 4, because 5 times 5 times 5 times 5, or 5 to the 4th power, is equal to 625. Cool, so logs can be really useful to help us solve. Some things to look out for. A lot of times we do have a base written here, so you'll see a subscript, a small dropped down number that'll tell you what the base is. So here we have a base of 5. Often though, most commonly, we will not see a base at all. It'll just be a blank space here, and that means the base is 10. This is called the common log. And finally we have the natural log. So the natural log says ln instead of log natural, it's French. And the base of that is a number called e, which we'll talk about more in the future. Sweet, so pretty much if we don't see a number here, then that's going to be a base of 10, unless we see this slightly different looking log, which we'll worry about later. Okay, we talked about in class about using calculators to help us out. Desmos does a really good job of allowing us to put in whatever base we want, but some calculators are limited here, so you want to be careful. All right, so in order for us to use logarithms, these are kind of new, and the first sort of skill we need to develop is to translate logs to exponents. So any logarithmic expression can be written as an exponent and vice versa. So here's the basic outline of how that works. So if I have log with some base of x is equal to y, that's the equivalent of saying that same base to the yth power is equal to x. So again, this is new, so it might be a little bit confusing at first, but this is the basic idea. Saying 2 to the 5th power is equal to 32 is the same thing as saying log base 2 of 32 is equal to 5. And it's hard to wrap your head around at first, so that's why we're practicing this right now. Okay, so there's a couple different tricks we can use to help us remember how to translate logs. The first trick is the way I learned it, and that's the way I still think about it, is the log loop trick. So it can always be confusing to make sure you're getting the numbers in the right place. So if you start at the base and you draw a loop, you can easily translate from logarithmic to exponential power. So I'm looking at this log, and I'd say it out loud. I'd say, all right, so base of 2 to the 5th power is equal to x. And the loop also works the other way around. So log base 2 of x is equal to 5. So the loop can help you. That's one way to do it. Another way I've learned is bin the log bunny. So we've got some base to an exponent is equal to some number, right? And you see it spells out bin. And that is going to be the same as log bunny, B-N-E. Get it? Bunny, bunny, bin, the bunny, the log bunny. It's very stupid, but it will help you remember, I promise. So it helps you remember what goes where. So the base always goes down here. Our answer in the exponential is the argument of the log, and finally the actual exponent is the answer to our log. So to help us, I'm going to do a couple practice problems with you now, since you missed class or whatever. Okay, which one do I want? I want this one. Okay, so essentially any exponential can be written as a log, any log can be written as an exponential. So one of the ways we can do this is to think about Ben. So Ben, the log, Benny. Or we can use the logarithm loop trick. So actually what I'm going to do here is I'm going to redo this to make it better. So we got log bunny. I'm going to color code this because I think that's super helpful. Okay. Sorry, being very particular about my colors. Okay, so Ben the log bunny is going to be there hanging out to help us remember what to do. Okay, so we can just, kind of think about this. We got 2 to the 6th power equals 64. So the base goes into the subscript, the base of the log. So it's going to be log base 2. The answer in our exponential is the argument of our log. So log base 2 of 64 is equal to the exponent is equal to 6. And again, I'm just using this little trick, Ben the log bunny, to help me remember where everything goes. We can also use the loop trick. So we'll start at the base and go counterclockwise. So we've got log base 4 of 4 is equal to 1. Okay, I'm going to try the loop trick again here. So log base 5 of 0.04 is equal to -2. So log base 5 of 0.04 is equal to -2. Now, notice a few things. When I'm writing these out, you want to kind of dramatize how small and low this number is. The worst thing is when I see students turn things in and I can't tell what they're trying to say, right? Log base 4 of 4 is very different than log 4, right? This doesn't look right. This looks like log base 10 of 44. So just be really explicit about which number is the base. So small, superscripted, right? And which is the actual argument. All right, last one here. Again, I'm going to use my loop trick, but Ben the bunny is a good way to do it as well. So I got log base 3 of 81 is equal to x. Okay, so that's all we're doing here is just translating. We don't care what x is, although we could figure it out. 3 to the 4th power is 81, but that's not what we're doing here. Okay, so let's translate the other way around. So the loop works to go either direction. So this log is telling me I got 10 to the 2nd power is equal to 100. That makes sense. Okay, or we could use Ben the bunny. So our base goes here, so 7. The answer is our exponent, so 7 squared. And finally, the argument is our our number here. Sweet. Again, we can verify this makes sense. 7 squared is 49. I'm going to go back to the loop trick because that's what I like. 8 to the -1 power is 0.125. Remember a negative exponent? Sorry, a little tangent here. 8 to the -1 is equal to 1 over 8. Remember, a negative exponent will take that base and drop it to the denominator and then make the exponent positive. So 1/8 is 0.125. And finally, 12 to the 0th power is equal to 1. Anything to the 0th power is 1. All right, we're going to do a couple more examples here. This time we're going to actually do some calculations. So there's a couple ways to do this. Log base 5 of 25. If you become fluent and you can look at this and you know what that log is asking you, what is the exponent is what it's asking you, then you can just go ahead and solve this. I can tell this is telling me what exponent would I have to raise 5 to get 25? 2. However, when you first start out with logs, it's hard to get there. It's hard to get fluent where you can just look at this and know what it's asking. So what I like to do is to use bend the log bunny or our loop trick to translate this. So think about, what is this asking me? It's saying 5 to what power is 25? Oh, 5 squared is 25. That's how we got the answer. It's 2. So for now, all right, you can use one of these tricks to translate first, but hopefully we want to get to a place where you look at a log and you understand it on a level where you can just come up with the answer. All right, here we got 2 to some power is equal to 32. So again, I'm going to think about it like this because I know exponents better. 2 to some power is going to give me 32. Okay, 2, 4, 8, 16, 32. So if I multiply 2 times itself 5 times, then I get 32. All right, so we can keep going like this, but I also want to show you that we can do this in a calculator. So if you're using a TI calculator, then you can put a log with any base you want into your calculator by clicking the math button and going down to where it says log base. That'll allow me to put something like this in here, log base 3 of 27. It'll give me the answer. The answer in this case is 3, because 3 to the third power gives me 27. But sometimes our log answers aren't so obvious. Let me show you one more calculator here. Get a fresh Desmos for you. So Desmos also does a really good job with logarithms, so this might be an option you want to use. What was this one? And again, I know what this answer is right away, but just for practice using the calculator, we can do log base 10. So the way I got down there was using an underscore, but there is a keyboard thingy for it as well. Again, you might need to play around with this a little bit. Yeah, so down here, so you gotta open the keyboard on Desmos, go over to functions, and then log base, and that'll let you type in whatever you want. So a shortcut for this is to use the underscore button. It's the key next to your 0, just like a load line, right? This underscore. Anyway, so that's a shortcut. Okay, and then you can type that in and Desmos will tell you the answer is 2. So practice using a calculator for logs, because not all calculators can handle this very well. Or use bend the log bunny to remind you this is 10 to the x power is 100. Oh, well, 10 squared is 100. All right, so some of these are slightly different. Notice that all of these questions had an x as the answer. So they're all asking the same thing. What exponent do we need? However, these are a little bit different. So let's translate them. And again, we can use our loop, but just for practice, let's remember bend the bunny. I'm trying to do this without writing it all out first, and I'm very confused. I did it. All right, let's remember bend the bunny here. So this is telling me that I've got x to the third power is equal to 64. Is there anything that I could raise to the third power to get 64? So we could think through it, and we'll come up with our answer is 4. Right, 4 times 4 is 16, times 4 again is 64, yeah. Or I could take a cube root of both sides if we want it to be a little more direct, or if it wasn't an obvious one. Okie dokie, let's try again. I got 2 to the fourth power is equal to x. So this one's actually asking for the argument, the answer here. So 2, 4, 8, 16. All right, we got, again, thinking through bend the bunny, we got x is our base, 2 is our exponent, and 400 is our answer. What squared would give us 400? 20. And again, you could take the square root if you're not sure. All right, and finally, 19 to the 0th power. Well, anything to the 0th power is always the same. It's 1. All right, so if you missed class, hopefully this was a good kind of review of how to do those translations, how to change something from log form to exponential form. That way we can answer it, or go from exponentials to logs if we need to. Thanks, guys.